All right, guys, this is our second video for Hess's Law. It's Tuesday, March 24th, and I'm going to show you one more example, this time working with 3 puzzle pieces, and then I want you to make sure you're practicing the other ones at home for me. That would be great. So once again, I'm going to cross out those moles. Okay. Yes, enthalpy is in kilojoules per mole, but again, when it's given after a balanced equation, you can put your kilojoules over any molar quantity in that equation. So let's look at this one down here. These are both very similar. They're both combustion reactions. You can see we are taking a hydrocarbon fuel. And what do we need to burn? We need oxygen gas. And we always get carbon dioxide gas and water vapor as our products. And that should say gas right there too. Sorry, noticing some typos, but that's good. Can we recognize little errors and typos in things? That's really good work if we can do that. Alrighty, so this is our balanced equation that we want. Notice our reactants, right? Reactants are always to the left of the arrow and products are always to the right side of the arrow. And then of course, notice the amounts that we need there. Now we're only worried about the things that are up here. We are not worried about anything else in any of the puzzle pieces. Okay. Alrighty, make sure we look at one puzzle piece at a time. So I'm going to cover up the other one so my eyes don't wander. And what do we have here? Okay, so it's talking about carbon. Do we have carbon up here? There's no carbon anywhere. I don't care about it. Hydrogen gas. These things start to panic me. Well, guess what? We don't need to worry. There's no hydrogen gas up here. What about this C2H6 fuel, our little hydrocarbon fuel? This is actually called ethane in organic chemistry, but you don't need to know that. Well, yes, we do have C2H6 up here, but we've got a problem. What's that problem? Here, it's a product. We need it as a reactant, okay? So we're going to have to flip this equation. So we're going to reverse this equation because we need to fix that placement, right? It's like you're sort of turning around your puzzle piece, just like if you were doing a puzzle at home. Now, what else is wrong with our little C2H6? Well, here we have 1 mole and we need 2 moles. Taking a glance, I don't see C2H6 repeat itself anymore, so we need to fix right now. So we need to double our recipe, just like if you wanted more cookies, right? Often we double our cookie recipe. So I've got to double all of my reactants, so my product doubles. So we're going to reverse this, and we're going to multiply everything through by 2. Those are the changes. You can do more than one change to a reaction. So we're going to flip it, and we're going to double everything. So we're going to do that in just 1 second. Let's look at our second puzzle piece. Our carbon. Don't worry about carbon. It's not anywhere up here. Oxygen, we do need to worry about that, okay? So we have oxygen here as a reactant. We have oxygen here as a product. So this is good. The placement is good, but the number is off. Here we have 1 mole. Here we need 7. Now, before we get ahead of ourselves and start multiplying everything through by 7, you need to check everything here. Now, we have carbon dioxide here as a product, and we have carbon dioxide here. The placement is good. They're both products, but the number is off. Here we have 1. Here we have 4. So the question is, do I multiply by 7 to fix my oxygens, or do I multiply by 4 to fix my carbon dioxides? So what did we do last time? Well, we look at our other puzzle piece and see if anything repeats itself. So scanning, scanning, scanning. There's oxygen. There's oxygen. We're going to get another opportunity to fix oxygen. So what are we doing? We're going to fix CO2 before oxygen, because we can fix oxygen in the next reaction. Okay, so we'll work on it later. Okay, but we need to fix the CO2 now. This is our only chance to fix the CO2. So again, the placement is good, but we need to fix our number. So we're going to multiply this whole thing through by 4. Okay, and then looking at our final puzzle piece, the hydrogen, not to worry, it's not in our overall. We have half a mole of oxygen gas here. Fractions start to freak me out a little bit, but I'm not going to worry about it. Okay, our oxygen's in a good place. It's a reactant. Let's look and see if we can worry about something else and then hope our oxygens work out. Well, here's our water vapor. Here it's a product. Here it's a product. Okay, we need to fix the amount of water now. There's no other chance to fix it. We've got to do it now. We have 6 moles, we have 1 mole. So we're going to multiply this through by 6 to fix our water, and we're going to keep our fingers crossed that that process fixes the oxygen. And it definitely will, because you have fixed everything else properly. So we need to rewrite everything. Okay, so our first equation, we reversed it and doubled it. So now we have 2 moles of C2H6 forms 4 moles of carbon and 6 moles of hydrogen. Now we also have to reverse our sign here. So that is a positive 84.7, and we need to double that. Excuse me. So let me actually just do that on my calculator really quick. I should be able to do that in my head, but hey, we're all tired. So this is a positive 169.4 kilojoules is what we have. We reversed and we doubled. So the sign flipped and we doubled our amount. Okay, looking at our second puzzle piece, we didn't reverse it. We just multiplied it through by 4 to fix our carbon dioxide. So make sure our arrows line up. So we've got 4 carbon plus 4 oxygens go to 4 CO2s. And then, of course, we need to take our enthalpy and multiply it through by 4, okay, and get that number. All right, so that gives us a negative 1574 kilojoules. So that is all good to go. And then looking at our third puzzle piece, we're almost there. We have multiplying the whole thing through by 6 to fix the waters, keeping our fingers crossed that it fixes the oxygens. So we have 6 moles of hydrogen plus, well, what's 6 times a half? That would be 3 moles of oxygen makes 6 moles of water. Okay, and then how does that affect our enthalpy? Well, can't do that in my head. So we are going to multiply that out. And I'm getting negative 1450.8 kilojoules. Okay, so we have all of those things there. All right, let's sum up our equation. So Hess's law, the summation of these elementary reactions should equal our overall. So we're adding all of these things up, canceling out anything that is the same on the left and the right, or reducing any numbers. So we've got 6 hydrogens on the left, 6 hydrogens on the right. We have 4 carbons on the left. We have 4 carbons on the right. And now we've got our overall. So we have 2 moles of C2H6. React with, what do we need to burn? That oxygen gas, and looky, we have our 7 moles of oxygen gas. Yahoo! The oxygen that we didn't fuss about worked itself out. And then we have 4 moles of CO2 as our products and 6 moles of water. Okay, so that looks like our balanced equation above, and now we just need to add up all of our enthalpies. One of them is positive and 2 of them are negative. So bear with me for 1 second. All right, so that's negative 2855.4. It should be negative. This is a combustion reaction. They're very exothermic. That's how we get heat energy. All right, so your job then is to finish up the other Hess's one for practice. Next video coming out pretty soon will be how to find heats of reaction or enthalpies of reaction using heats of formation or enthalpies of formation. Notice I keep using heat and enthalpy interchangeably, kind of like slang words, but enthalpy is specifically heat per mole of a substance. So stay tuned. I'm going to go upload these, and I've got a conference call to learn how to do some of this online teaching that you guys are working with too. And I think we're doing a great job. So keep up watching those videos. I can see that you're doing that. Keep up doing your homework. Don't forget to stay on top of any online quizzes, and I've been giving you lots of notice there, and more information concerning your exams will be coming soon. Miss you guys. Talk to you later. Bye.